Hello, I'm Tajor, and this video is about our assignment on some simple electromagnetic and electrostatic experiments and their applications in real life. Me and Nuria Hanim, we're in the same group and we're gonna present on this video respectively. So now let's jump into the experiments. We're gonna be requiring a copper wire, AA battery, and something that is a ferromagnetic metal. So here I'm using my steel knife for it. So now let's first look at the neutral knife and how it does not attract to any metal that is put closer to it. Okay, so now we can say the knife is completely neutral. Now we take the copper wire and make a solenoid like this, and then we put the knife in the core of the solenoid. Now we connect a battery in the system to make a current flow through the core in the metal, which is our steel knife. Now we disconnect the battery and see if our knife has become a temporary electromagnet. So for that, we'll test it with the metal safety pins that we have brought. And now you can see the knife successfully attracts the metal which is put closer to it, just like a magnet should do. So basically what happens here, when we make a solenoid of the copper wire and put it around the knife like we did in the video, and connect a battery to make a current flow through the knife, it turns the steel knife into a temporary electromagnet. So it gets the same characteristics as the magnets should have. So when we put any metal closer to it, it attracts it just like a magnet should do. But yeah, these characteristics of this temporary electromagnet is temporary. It's gonna fade as time goes by. So after a certain point of time, the knife is gonna lose its temporary electromagnet characteristics and come back to its neutral form again. The polarity of this electromagnet can also be changed by changing the direction of the current, and the strength of these temporary electromagnets can also be increased by increasing the number of turns in the solenoid and the current flow through the metal in the core. One of the real-life applications of this electromagnet is in electric bells. When we press the switch of the electric bell, the electricity starts to flow through the wires, through the solenoids, and making the metal in the core an electromagnet temporarily. The magnet attracts the hammer, and the hammer is detached from the screw and hits the bell, and it produces the sound. And as soon as the hammer is disconnected from the screw, the circuit is also disconnected, so there is no current flow. So the electromagnet just loses its temporary characteristics, and so the hammer goes back to the screw again, completing the circuit. And as the switch is already pressed, the current again starts to flow and repeats the same process. Thus the hammer keeps on hitting the bell repeatedly, creating the sound. So that's how the electric bell works. There are also some other uses of electromagnet, especially the one that we're gonna show in the experiment 2 as well. So let's check it out.
Hi everyone, this is Nuria, and based on our assignment on electromagnetic theory, we have chosen our second experiment on how to make a simple motor. So let's have a look at how we have created it. For this experiment, the equipments we need are an insulated copper wire, an UPS battery, a strong magnet, 4 nails, and an anti-cutter. At first, we have wrapped the copper wire around a cylinder 10 to 20 times to make a coil. Now leave some portion at each end of the wire and cut about 3 cm there. Smoothen the ends of the wire like this using the anti-cutter and place it firmly between the 4 nails. And give it a spin. If it doesn't spin easily, change the shape of the wire. Connect the UPS battery with the help of wires connecting to the ends of the coil. Now give it a push and bring the strong magnet closer to the moving coil. The coil keeps on moving without any further push. So, what's going on in here? The coil keeps on moving and moving. The current flows through the battery and then to the wire coil, creating an electromagnet. One face of the coil becomes a north pole and the other a south pole. The permanent magnet attracts its opposite pole on the coil and repels its like pole, causing the coil to spin. The permanent magnet exerts force on the electrical currents flowing through the loop of wire. When the loop of wire is in a vertical plane, the force on the top and bottom wires of the loop will be in opposite direction. These oppositely directed forces produce a twisting force or torque on the loop of the wire that makes it turn. The direction of current and the direction of magnetic field can be easily understood using the Fleming's left-hand rule. In this motor, the sliding electrical contacts between the end of the coil turns off current for half of its cycle. Such sliding contacts are known as commutators, and more complicated commutators are used in DC electric motor, which is used to reverse the direction of current flow through the loop every half cycle. Now let's have a look at the application of this motor. These motors are used in fans, blowers, pumps, turbines, ships, tools used in machines, movers, rolling mills, compressor, alternators, and paper mills. These are also the most important devices in heating, ventilating, and cooling equipment, motor vehicles, and home appliances. That was all about our assignment based on electromagnetic theory, and hope you guys like our experiments. Thanks for watching.